I don't know whether we have ladies. I don't know whether we have ladies in this meeting, but let me take this opportunity to welcome you to our today's lesson. The topic is biomechanics. Our presenter, as you can see from the screen, is Dr. Michael Tank, PhD from the University of Nairobi, Department of Physical Education in Sports. So Dr. Tank will take us through today, and please welcome and of course help me welcome Dr. Tank to take over. Thank you.
Yeah, thank you very much, John. I hope I can be heard. Sometimes it's good
Sure,
to
we
test.
can hear you.
Yeah, thank you. Let condense my presentation into a PowerPoint. I work in two universities, and there's been a lot of pressure in the last 1 week. But what I can promise is that I can be able to do that and send, maybe through John, send by email, so that we can have the presentation much later on. Otherwise, I'll just take you through uh, the concepts that I want us to go through. And mainly, I want to emphasize a lot on application. I've got about 8 particular concepts that I want to take us through, and we'll probably do that in the next 40 minutes and maybe have about 20 minutes of Q&A. So first of all, as it had been put on the screen there, this course in biomechanics, usually the objective is that we want to seek the learner to know about the tools of mechanics and their impact on the human body for quality execution of skills. And again, the acquisition of skills through the human body movement patterns in biomechanics. Out of this, it is expected that coaches will develop their coaching plans with in the context that they understand the body and the way it operates as a machine. So the expected outcomes would be that the learner, or let's talk about the learner, should be able to explain the concept of biomechanics and its application to skill acquisition in sports, and also to apply the principles of body movement and how they impact on the acquisition of skill. Then this now will be allow allow the learner to be able also to differentiate the different types of liver systems. And I'm going to cover that as one of the areas, because the body at the end of the day is just a machine, like a car. And that is how it operates in terms of human movement. So those are basically the expected learning outcomes. And I'll probably start by just a definition, because normally we have two terminologies that should be explicitly defined. There is biomechanics and there is kinesiology. Now, kinesiology is really what I'm hearing some echo. So I don't know if somebody has the mic on, but please mute. Please mute so that we can get rid of that echo. So kinesiology basically is the study of human movement. It's the science of human movement as a whole. And then when we come to biomechanics, we are looking at now, how does the body, the internal mechanisms of the body, the bio, now apply to generate human movement. Since bio refers to living, and mechanics refers to forces acting on the objects, then we want now to understand
Say again.
how so we are now looking at basically how does the internal forces generated by the muscles now interact with the external forces that you have, for example, gravity, friction, and air resistance. How do these forces interact to be able now to produce human movement in order to enhance the quality of a sports performance? So, biomechanics, in a nutshell, biomechanics is is a subset of kinesiology. Now, the importance of biomechanics in sports is something that cannot be overemphasized. I have collapsed the importance into actually two major aspects that we would expect really coaches to look at. Of course, first of all, we are talking about the improvement in performance because human movement can be enhanced in so many ways. Effective movement involves now the anatomical factors that you have in the body, the neuromuscular skills that you have in the body, the physiological capacities that you have, and of course, there is always the psychological and the cognitive. So, biomechanics takes into account all these aspects that we are talking about, and it's a most useful way in improving performance in our sports or activities where technique is dominant. And I want to emphasize on the aspect of technique in terms of acquisition of skill and how do we acquire that skill, and then how do we train that particular skill to be able now to get quality performance. So that is one importance of biomechanics that I would like to emphasize on. The other one is, of course, reduction or treatment of injuries. Movement safety or injury prevention is another primary area where biomechanics can be applied. It is very important that we emphasize to our coaches the coaching of correct technique so that we can prevent. Sometimes it is better to prevent the injury rather than the injury occurring, and then you go into now rehabilitation and aspects of return to play. So, sports medicine professionals have traditionally studied a lot of injury data to try and determine the potential causes of disease and injury. So, biomechanical research is a powerful uh, ally in the sports medicine area in terms of how to prevent and sometimes even to treat the injury. So, in a nutshell, what I'm saying is that the study of that quality, acquisition of skill to be able to get quality and to be able to get our players to actually perform using the correct technique is a way in which injury prevention can be effective. And more so, especially when we go to conditioning, biomechanics comes out very, very strongly in the conditioning aspects and the conditioning techniques to be able to help in that prevention of injury. So we are talking about uh, quality acquisition of skill to be able to enhance performance, and we are talking about reduction and also in the treatment of injuries, especially when we are talking of return to play protocols where players have recovered from an injury and you are now getting the player to get into back into competition. I just want to go very quickly and identify a few terms, concepts that are related, but maybe just to go back, biomechanics is actually divided into two aspects. Again, it's an area that I was forgetting. We have kinetics and we have kinematics. Now, kinetics deals mainly with the forces that generate movement, and kinematics now are concerned with that geometry of that motion, or now looking at how that movement has occurred. But kinetics deals with the actual forces, and then kinematics deals with how do you look at the study of that movement as it is occurring? So there are some concepts that are related to kinetics that I want to go through very fast. Uh, and these are, first of all, we want to look at inertia. And we'll look at this inertia later on in one of the aspects when we are looking at Newton's laws of motion. But inertia just means a tendency of a body to maintain its current state of motion, whether it is moving or it is not moving. Mass, and this again very important. Sometimes we confuse mass and weight. Now, mass is the amount of matter that you have in the body and measured in kilograms, in the kilograms. While weight is defined as the amount of gravitational force that is exerted on that body. So weight is normally equal to mass times acceleration due to gravity, which is 9.8 meters per second per second. Uh, Another item that I want to really concept that I want to really define is the center of gravity. A very important aspect that plays a big role, especially in stability in contact sports. So our center of gravity is the point around which the body's weight is equally balanced, no matter how the body is positioned. And the location of this center of gravity determines the way in which our bodies will respond to external forces quite a lot. Contact sports, especially, usually we need to lower our center of gravity to be able to maintain stability in contact sports. So, center of gravity is an area, is a concept in kinetics that is very, very important. Another one is pressure, which is force distributed over a given area. Volume is the amount of space a body occupies. Density comes into now water dynamics, where we have combines the mass with the body volume, which is mass per unit volume. And then lastly, power, because this is another important concept that is normally confused with hypertrophy, increase in muscle strength. Now, power is actually the ability to exert force in the shortest period of time, and focuses on the ability of the body of the muscles to overcome resistance. So we are talking about time when we deal with power. So it is the amount of time, or now we are looking at the contraction. How fast does the muscle contract when we are talking about power? So just now to move on, after that introduction, I'm going to go very quickly through mechanical loads, forces, Newton's laws, mechanical behavior of a body in contact, that is friction, projectile motion, and we'll finish off with human movement in water. I hope I can do this in the next 30 minutes or so, and then we will have a Q&A session. So when we talk about uh, mechanical, let's go to mechanical loads of bodies in contact after that introduction. And we now need to look at probably the forces and injury to the human body. And I would like to probably refer more to training in the gym when we are lifting weights. Now, the forces that normally affect us when we are putting pressure on the body, especially the back, we have tension, which is a pulling force. We have compression, which is a squeezing force. We have a shear, which is a tearing apart force. And we have torques, which are twisting or a twisting force. So tension, compression, shears, and torques. Now, the factors that usually affect the outcome of these acting forces are duration, how much time, how much time have we put that body under that stress, direction, what direction is the force coming from, magnitude, and the distribution of those forces. Now, the transmission of weight in the human body, if you look at the backbone, the vertebral column, and we have the vertebral bones. Now, the structural adaptations of the vertebral bones have, have made us be able to transmit a very huge amount of weight from the upper part of the skeleton down to the lower part of the skeleton without really feeling the pressure. You can carry a body mass of probably 80 to 100 or even 110 kilos without really feeling the pressure. That is because of the adaptation of the vertebrae, especially the lumbar vertebrae, which have got the centrum of the lumbar vertebrae is very, very much defined so that the transference of body weight happens down to the lower extremity without a lot of stress. But nevertheless, it is important that stress is not put on the back to be able now to generate back pains and situations like that. A lot of causes of the back pain when we are training, for example, in the gym, a lot of times you've got postural postural issues. The position in which you hold your body while standing or sitting could affect your back and cause some back pain. So good posture involves training your body to stand, walk, and still, and lie so that you place the least strain on the back muscles and the ligaments. Another cause of back pain could be discogenic, which means that probably degenerative changes of the intervertebral disc could have some structural defects if pressure again is put on the back. Then you can also have a muscular strain on the back if you don't do the training in line with maintaining the right body position. So we need to prevent lower back pain by encouraging the athlete to maintain good posture while training. You sit and stand straight with your shoulders and back, or even when sitting or sitting on a chair, you must sit with your back straight so that you have some good support of the lumbar vertebral bones. It is also important to wear the shoes, good shoes, invest in comfortable shoes while training with low heels to prevent unnecessary strains on the back. We should also perform low impact exercise while walking, swimming, biking. They are great ways to stay in shape and strengthen your core muscles while maintaining good posture. Physiologically, you can also watch your diet in terms of the kind of food that you eat, and also when sleeping, it is important to ensure that you sleep more or less the surface on which you're sleeping in should not be curved, and it's also important to avoid sleeping on your back. So those are some of the things that we would emphasize on when we come to mechanical loads that we put on the body in terms of stress. To move very quickly now to the next aspect is forces, and this forces is really the key aspect of kinetics when we come to kinetics. Now remember, a force has got both magnitude and direction. And a force, therefore, qualifies as a vector quantity. I believe with your background, you know the difference between scalar quantities and vector quantities. In a nutshell, scalar quantities possess magnitude but have no direction, while vector quantities possess magnitude and have direction. The vector quantities, some examples I can give apart from force are weight, pressure, and you also have displacement, velocity, acceleration. And scalar quantities are concepts like mass, volume, work, energy, and etc. Now, the aspect of a force qualifying as a vector quantity enables us to be able to use now the to use now vectors and the the qualities of vectors to be able now to solve forces and resolution of forces in sports using now the uh, let me say the components of vectors that we associate with vectors. So when we look at the aspect of vector resolution, we can be able to solve, especially when you're dealing with forces that occur on one plane. Then you can use the qualities of solving vectors to be able to also solve the resolution of forces. And usually you can solve vector resolutions by using either graphic solutions or use trigonometric functions. A lot of times in biomechanics, we use the trigonometric functions of right triangles. You use the Pythagoras theorem and the three trigonometric relations based on right triangles, the sine, cosine, and tangent to be able to help us in solving resolution of forces, because a force and a vector just qualifies on the same aspects, like they both have magnitude and they also have direction. Remember, the trigonometric relationships of sine, cosine, and tangent only apply to right triangles and also the Pythagoras theorem. But you also have a useful trigonometric relations or the law of sines and the law of cosines to be able to help in the resolution of these forces. I want to focus more. I will not go into the technicalities of how we resolve those ones, but I want to focus more on now the application. For example, if you have a weightlifter, a coach is assisting his athlete maybe with a bench press, and you have a weight of 110 kgs. The coach is acting on this barbell probably with a force of 80 newtons, and the athlete is exerting a force of 960 newtons in an upward direction. Now, maybe the question that we would ask here is, will they manage to lift this weight? And then what would be the resultant force now acting on this weight when you take the coach's force of 80 newtons and the force of the athlete of 960 newtons? How would you now get the resultant force that will now enable this weight to be lifted? That is just an example of how this resolution of forces using the relationships of vectors, the trigonometric relationships of vectors to help us in solving a problem of that nature. You also have aspects that you can do in cricket when the batsman hits the ball, the angle at which he shoots or he bats, and the amount of velocity with which he hits that ball are important factors that you can determine, that you can use to determine whether that ball will go over the boundary or not. So those are just two examples of applications in terms of resolution of forces that you can use or how they help us in determining the resolution of or determining the resultant forces rather when you have two forces acting probably in different directions and you want to find out what is now the magnitude of the resultant force in a particular spot. I'll move now to the next one of Newton's laws. Now, I always tell people that this gentleman, and I'm sure everybody knows about Sir Isaac Newton from our physics background. Now, this is a gentleman who was born in 1643 and he lived for 85 years. And I sometimes wonder how somebody who was born in 1643 uh, came up with three laws that we still use up to now in physics, and they also come in sports in quite a big way. Of course, you know about the three laws. The first law is the law of inertia. A body tends to remain at rest or stay in motion, in uniform motion, and in the same direction unless acted upon by an outside force. You have the second law, the law of acceleration, which states that the velocity of a body is changed only when acted upon by an additional force, and the produced acceleration or deceleration is proportional to and in the same direction of the force. Of course, it is normally represented in the formula of force is equal to mass times acceleration. And then you've got the third law, which is called the law of counterforce, where we say that the production of any force will create another force which will be opposite but equal to the first force. I'll just give one example of how a principle of each of these laws is related to a sporting activity. If we look at the first law, the law of inertia, we talk about a principle where if you combine a translatory action with a rotary motion effectively, it will always lead to a successful performance. An example is the discus throw. The discus throw has got three aspects of motion that the athlete normally executes before we can get that discus to be thrown. You have got the initial translation where the athlete moves from the back to the front. That is a translation. Then you've got now the rotary motion of the body as it turns. There is that rotary motion of the body. Then you've now got the rotary motion of the arm when it swings, that arm. Now, if all these forces do not, for example, if all of them do not follow one another, are not combined effectively, such that one follows the other immediately, then that successful performance of the discus throw might not be achieved. So that is just an example of a principle that you can say is related to the law of inertia. If we come to the law of acceleration, and we can take a principle like maybe let's look at effects of momentum, for example. And this is a good example in contact sports, especially rugby, which is my specialty. Now, momentum is a product of mass times the velocity. Therefore, if you want to increase momentum, or if you want to vary the momentum, then you have the two variables of mass and acceleration. But usually, to manipulate, it's not very easy to manipulate mass because mass is a constant at any time when you're training. You can only manipulate mass when you probably go into off-season training. You are trying to get to increase the hypertrophy or to increase the size of the muscles. But manipulation of mass when we are training is very, very difficult. It's a constant. So a lot of times the variable that we can manipulate is the acceleration to increase momentum, right? So when you're training, then you must train the athlete on speed work to enable him or her to increase the acceleration in order to increase momentum. So that is an example, the effect of momentum because it is a product of mass and the acceleration, either of the components can be increased. But mass takes a bit of time in training to increase. Increase in mass, again, would be advantageous if acceleration or if velocity is not lost. Sometimes you have athletes going to increase mass in training when they are in the gym, and then you lose the velocity. Then, of course, you will not get that desired increase in momentum. A third, when we come to Newton's third law, that's just one example of a principle associated. There are many more. There are about 6 more. When we come to the law of counterforce, then really a very good example is just when you are executing the vertical jump. Perpendicularly, you will execute the vertical jump, exert the force on the ground, and the ground will exert an equal force, but in the opposite direction. And that is what enables you to jump. Another very good example is in the athletes starting blocks in the short sprints. Usually, if you want to direct the force horizontally when the athlete starts in the sprints, then the way that the starting block is aligned should be very, very important so that you can be able to transfer that force horizontally to enable the athlete to be able to achieve a proper takeoff. So that is another very, very good example of a principle that is related to the law of counterforce, Newton's third law. There are a number of other principles which, because of time, I would not be able to go through them. But I just wanted to highlight that so that we can be able to see the importance of the application of Newton's laws in our sporting activities. And a lot of it happens, and it is therefore important for the coaches and the athletes to understand some of these principles in order to achieve that quality acquisition of skill to enable us to enhance performance. I will go very quickly now into the aspect of friction, mechanical behavior of bodies in contact. Friction is one of the external forces that we have that come in, and we have to see how to deal with this friction to be able again now to get that performance enhancement. Friction is a force that acts at the interface of surfaces in contact in the direction opposite the direction of motion. If it was not for friction, I don't even think we would be able to generate movement. Now, what I want really to emphasize on here is that there is something called the coefficient of friction. It is a unitless number that indicates the relative ease of sliding or the amount of mechanical or molecular interaction that is there between two surfaces. It is a unitless number. The greater the mechanical and molecular interaction that you have, the greater the value of this coefficient of friction. It is a value between, usually in sports, it's a value between 0 and 1, but I believe in physics it can go up to 3. Really, what this coefficient tells us is that if you have a contact, for example, an athlete has a contact of the shoe with a ground, and the shoe indicates that it has a coefficient of friction of 0.8. And maybe another athlete has got a shoe with a coefficient of friction of 0.4. What that tells you is that the person with a higher coefficient of friction of 0.8 has got a better grasping of the ground, will not fall, will be able to to have a firmer grip on the ground, as opposed to somebody who has a lower coefficient of friction. A lower coefficient of friction means that you will slide more easily. And I think this is a value that is normally very important to sports manufacturers, because it tells you, it can help you to see how to link the manufacture of the footwear to the particular ground that the players are going to use. For example, in hockey, where you have AstroTurf, you cannot just go and play on AstroTurf with any type of shoe. This helps the manufacturers a lot to be able to manufacture the correct equipment that is necessary for contact with that ground. So that is one importance of this coefficient of friction that we have. Now, the coefficient of friction, I will not go into the technicalities of it, but usually it describes it. There are two coefficient of frictions rather that we normally look at. We have the coefficient of static friction, which is now just the aspect of the object is just about to move but has not moved. And then when somebody is in motion or an object is in motion, then we look at the coefficient of kinetic friction. Again, we will not go into technicalities of that coefficient, but on the application, I've already talked about the running spikes, where track and field athletes often wear specialized running shoes with spikes to increase that coefficient of friction between the shoes and the track. And then sometimes you also see athletes applying chalk to their hands, especially when you have a throwing event. Then that is all to do with, again, that aspect of increasing the coefficient of friction between the hand and the object that is supposed to be thrown. Even in rugby, where we have scrum machines, then we talk a lot about the coefficient of friction, because the scrum machine is supposed to have a very, very high coefficient of friction so that it does not move when the players are pushing against it. Then I want to go now into the human body as a machine. Again, another very, very important area in biomechanics. The musculoskeletal system is actually a series of simple machines. The liver system. The human body moves through a system of levers. Levers cannot be changed but can be utilized more efficiently. And remember, a lever is just a rigid bar that turns around an axis of rotation, which is a fulcrum, and then there is a load that is supposed to be lifted. Of course, we've got all those classifications of levers where you have first class levers, which you know very well as seesaw, where the fulcrum is in the middle and the load and effort is in the is at the extremes. And of course, you have the second class levers, where you have the effort is in the middle, and then you have the third class levers where sorry the second class levers where the resistance is in the middle, and the third class levers where the effort is in the middle. But what we want to understand here is that the lever bar in the body is represented by the bones, and then the fulcrum is normally the joint, and then the effort is the contraction of the muscle. And of course, the load is what you are trying to lift. For example, if you are doing the biceps curl in the gym, then the the point of insertion, the point of insertion of the biceps muscle becomes your effort. The joint, elbow joint, is the fulcrum. The load is the the weight that you're trying to lift with your hand. Maybe it is the weight that you're trying to lift with your hand. So, and you now need to remember here is that there are various examples of a first class liver in the body, various examples of a second class liver in the body. But what you need to take note of is that most of the liver systems in the body qualify as third class livers. Now, the relationship of the length of the liver arms is what really helps us in terms of this leverage. What again I want to emphasize on is that the system of leverage in the human body, because it qualifies as a third class, most of the livers in the body. Of course, there are a few that you can attribute to first class liver, and there are a few that you can attribute to second class liver. But the system of leverage is built more for speed and range of movement at the expense of getting a mechanical advantage. So that is an aspect that is normally studied quite a lot in the aspect of biomechanics, that will now lead to the application and see how this liver system comes up to be able now to help the body to move as a machine. So the body is just a system of levers, it's a machine. And now you need to see how to balance between now the length of the force arm vis-a-vis the length of the resistant arm, and how can you effectively be able to use this body and use as minimum effort as possible to produce the maximum amount of movement that you want with very minimal effort that is put in terms of training. So that is how the liver system comes in biomechanics, uh, and helping us also to achieve this aim of improved performance. Projectile motion is the next area, and this is again one of the most important areas that we need to focus on. Now, definition of a projectile. A plane is not a projectile. A bird is not a projectile. A ball that is kicked in the air from a goal kick that lands to where it is been projected to land qualifies as a projectile. A basketball that is thrown to when somebody wants to score in basketball is a projectile. The reason why a plane and birds are not projectiles, because a projectile is a body which is thrown and it is left only to be subjected to the external forces. A body thrown in the air and it is only subjected to the external forces, which is gravity and air resistance. So a plane, because it has an engine, and a bird, because it uses its wings to fly, cannot qualify as projectiles. A ball that is kicked in the air, a goal kick, a soccer ball, will qualify as a projectile. A ball that is kicked, a rugby conversion, will qualify as a projectile. Because after it has been kicked by the initial force, it is now only left to be subjected to the external forces, mainly the force of gravity and the air resistance. A lot of times, if you want to study projectile motion, you must divide the, the projectile motion into a horizontal aspect and a vertical aspect. And this is an area again where trigonometry comes in. Because if you want to study that projectile motion, the vertical aspect, it is gravity that is acting on it, gravitational force. And remember, gravitational force, when you kick a ball upwards, it reaches a point when it will now no longer be going up and then it starts coming down. Air resistance sometimes can be assumed to be not negligible, but there are situations where you must take into account also the air resistance. So the study of projectile motions is when we take an analysis of the x-axis horizontally, and you create a graph where you have the y-axis vertically. And there are some equations of motion. Uh, I'm sure if you remember your physics, you've got those equations of motion where you have velocity, a final velocity is equal to initial velocity plus acceleration times time. Then you also have distance is equal to a half final velocity plus initial velocity over time. Then you also have final velocity squared is equal to initial velocity squared plus 2 times acceleration times distance. There are those equations of motion that that are normally used in analyzing projectile motion. Application in projectile motion is actually all in sports, even if it's your body, high jump, long jump, your body becomes a projectile. If it is a ball that you've kicked, it becomes a projectile. So it is very important for coaches to understand in terms of just, for example, if I want to get a goal kick to land to land in the intended place where I want it to land, then it will be important to know at what angle am I going to kick this ball, what kind of force must I give it, and how long will it take for it to be in the air before it lands in the actual target where I would want it to land. Same with a javelin throw. So projectile motion is very, very important in sports because you have a player kicking a soccer ball, you have a basketball player trying. Is it called dunking in a no in basketball? You have golf where you are teeing off. You have hockey where you are maybe scooping a ball. So a lot of all these sports that we have, projectile motion is very, very important because 90% of all sporting activities involve projectile motion. So very, very important in the analysis. And those three equations of motions are very important. And finally, I want to conclude, and I believe I've really tried to cover all this. I want to conclude with movement in water. And when we come with movement in water, we are talking about swimming. And of course, there are also other aquatic sports. It's not just swimming. We have aquatic sports like diving. We have aquatic sports like polo, water polo, and all that. Uh, we have a gentleman here again, just like Sir Isaac Newton, a gentleman who was called Archimedes, who came up with his principle of flotation, and that has also stood the test of time. Archimedes' principle states that a body in a fluid medium will experience a buoyant force equal to the weight of the volume of the fluid which is displaced. Usually, you have examples, so you create of a boat that is floating on a water body. Now, buoyancy is normally calculated as a product of the displaced volume and probably the fluid's specific weight. Now, the ability of that body to float depends on the relationship between the body's buoyancy and its weight, according to Archimedes' principle. When we are in water, then now the aspect of the center of gravity changes, whereby we now have also something called a center of buoyancy and a center of volume. What I want to emphasize here is that a lot of tactics in swimming includes normally elevating this center of buoyancy so that it probably lies closer to the center of volume because you want to reduce as much torque or turning activity in water as much as possible to maintain a streamlined shape. But apart from buoyancy, in fluids, you also have a drag force and a lift force. And even within the drag force, you have two types of drag forces, surface drag and foam drag. So these are now the forces that are explicit to movement in water that you don't probably, you could also experience them in, because the air is also a fluid, but they are more prominent when we are in water and when somebody is swimming, as opposed to the effect that they have when somebody is subjected to air resistance on the ground. So these fluid forces, in terms of application, just to finish up, the fluid forces normally result in a considerable resistance to high velocity movements through fluids. So many sports techniques and even pieces of equipment in sports are designed to minimize the fluid resistance as much as possible. A lot of times the swimsuits are manufactured to ensure that the way they fit in the body, they will not come and contribute, or they will offer as minimal resistance to the water as possible. And also the mechanisms that are involved in swimming involve harnessing these propulsive forces and and also to ensure that you maintain the streamlined shape as much as possible so that you can be able to overcome these forces that you are subjected to in water. So, ladies and gentlemen, I must apologize again for not condensing this presentation into a PowerPoint presentation, but I promise that I will be able to do that, hoping that probably sometime next week, when I get a bit more of time from my university duties, and I will be able to circulate what I have talked about in a PowerPoint form for ease of reference. Otherwise, thank you very much for listening, and I now hand it back to John for maybe the Q&A session. Thank you.
Thank you, Dr. Tank. As you've rightly put it, if there's any question for Dr. Tank, anyone who needs any clarification, as we wait for people to compose themselves, maybe Dr. Tank, briefly, this knowledge that you've just shared, how can I just want to find out how can I use it, for example, to increase or produce a maximum force for my taekwondo athlete?
I think one of the most important things, John, that I've always emphasized on is uh, it is important to do an analysis of the movement for your athlete, because if you don't have a photographic analysis, then it is very difficult to apply this biomechanical knowledge. So for me, the most important thing is probably to photograph the movement and be able to look at how the movement is happening, and then you can go back to the drawing board and apply now the biomechanical knowledge in terms of like what we have talked about in forces, the resolution of forces, to be able now to guide the athlete that this is the way we can improve this technique. Because a lot of movement in terms of now when we are talking of projectile motion, angle of release or angle of contact becomes very important. And even before that, the approach, the way the athlete approaches the before execution of that technique is very important. We need to take cognizance of that. And then the point of contact with whatever object you want to push through, or if it is the athlete's body to be transformed into projectile motion, is very important. And then if the body is in the air, then how much time does it take to be in the air for you to get back to the ground to do the activity? So my answer is that we must get into a situation where we can analyze the movement. And these days we have phones, we have, really there is no excuse for somebody not being able to analyze that movement. But if the movement is not analyzed in terms of using a video or analysis, to be able to look at the movement and determine what is the right way in executing this movement of whatever sport, then it's going to be very, very difficult to apply some of these aspects of biomechanical knowledge to be able now to use it in enhancing performance.
That's quite clear. So video or photography must
Yes,
come in
must
place
come in,
first,
must come in.
and then
Let us
based on
start.
that,
Yeah, let us start coaching using the technology.
and then now you can design a program
Then you can design a program.
if you detect a weakness.
Yes, you can design a program, and you see also when the athlete can actually see, when the athlete can actually see that this is the way the movement has occurred, then it becomes much easier. But that old school way of coaching where you are not really analyzing it, you are probably just doing some guesswork, it's very difficult to apply the biomechanical knowledge.
Thank you. Any other person? Any person with a clarification or something that they would want Dr. Tank to explain more? Does silence means we've understood everything?
Maybe what I would suggest, John, is that we have more of this. We have rushed through. I
Right.
think what we need to do probably next time is to just get a particular concept, like two of them, and then we go deeply into it, and we can even come up with some videos and take people through, because sometimes it's very difficult to really conceptualize this aspect of biomechanics if we just rush through. So I take it like today's was just an introductory, but I think we should have more discussions when we just get two or three concepts and we go through them in a bit more detail.
That's quite in order. So
Yeah.
maybe we will work out on the best time. If not next week Friday, maybe the other Friday when the
Yeah, then we can itemize. And for example, for me, I would like to focus a bit more on the aspect of or projectile motion, because that applies to almost all the sports, and also the aspect of the human body as a machine. Those two, I believe, are very important, and we can just narrow down discussion on those two as we now see when we can do the others.
All right, there's a question in the chat box. Are you able to?
Let me see chat box. Oh,
I
in
can
fact,
read
I'm
it
seeing
out.
a lot of comments here. Please do.
Could you do a case study of the biomechanics of a specific sport item like javelin, etc.? So the
Yes.
question, if you can
Yeah.
do a study on biomechanics of a specific sport item like the javelin.
Yeah, that is very important. I mean, yeah, that is very possible. That is very possible. And that's what I'm saying, narrowing down to specifics. And in fact, projectile motion, which I'm talking about, the throwing events in athletics, there is a lot of application of biomechanics. Things like javelin, discus, pole vault, even the jumps, the long jump and the high jump. So that is very possible. It is something that we can look at and then discuss. So that is very possible.
All right. So Michelle, I hope your question is answered. Any other concern?
Thank you very much, Doctor.
Who is speaking?
Sorry, this is Michelle speaking.
Right. Michelle, where are you joining from?
I'm from Johannesburg, South Africa.
All right, thank you. Okay, so as the doctor said, maybe we could take some specific topics and then go deep into them so that we can all understand the mechanics or the basics, these theories, and yeah. So if there's no any other concern, then I think I'll have to take this opportunity to thank Doctor for availing himself and sharing with us. And he has promised to do more of such presentations. I will just let you know when he's available to do that. Otherwise, Daktari, thank you so much for your time. And we really appreciate the knowledge that you've shared with us.
Thank you. Thank you so much, everybody. And remember, I promise I will circulate the PowerPoint presentation to everybody for your reference. And I hope that we will have more of this. More of you will come on board. Thank you very much for listening to me, and I appreciate it.
Thank you. And whoever did not receive a direct invitation, you can share your number in the chat box so that you would be able to get direct invitations for this. And again, there is a link in our chat box. You can give a review so that we can improve on whatever we need to next time. Thank you so much, and have a good afternoon and good evening for those who are in Kenya.